All right, chemistry students, this is going to be just a quick reminder on how to do neutralization reactions so you can do the work in the packet. So these are not going to be the same ones in the packet. These are just some extra practice ones that I came up with to help teach this. So, as a reminder, anytime we have a neutralization reaction, we end up with two products. One of those products is going to be water, always. The other product is going to be what's left over. It's always going to be some kind of a salt. It doesn't really matter to us that it's a salt, but what we have left over after we've made the water. So for this first one, we make water right there, and then we have the leftover. Now, the acid is this guy right here. To make water, we had to use everything from the acid that makes the acid, which is that hydrogen. The base over here has that hydroxide. So use everything from the base that makes it a base. So all of that hydroxide, even that lowercase 2, that subscript 2, we still need to include that into what is in water. Now, you're going to be a little bit frustrated here because maybe it doesn't balance out the way that you think it should. We'll take care of that at the end. What we're left with then is calcium and nitrate. So now we have to come up with the correct chemical formula for calcium nitrate. This is where some of the stuff from before you have to remember comes in. Calcium is a metal, and we can go to the periodic table to figure out its charge. It has a positive 2 charge. Nitrate, on the other hand, is a polyatomic ion. We either have to go to that polyatomic ion sheet you got first semester, or we can use context clues. Hydrogen is a positive 1. The overall charge on this thing has to be 0 for the acid, which means that nitrate has to be negative 1. So if we have positive 1 and negative 1, that gives us 0. That means that nitrate is negative 1. This thing also has to equal 0. It doesn't right now. Positive 2 and negative 1 does not equal 0. So we have to then add a subscript. There's the 2. Now we have 2 negative 1s, a positive 2, and 2 negative 1s does make 0. So that's how we can do that one. Let's go on to this one down here because it's a little bit easier, and then we'll go back up to this one. So we started with one of the more difficult ones at the beginning. So we have hydrogen here. That makes the acid. We have hydroxide here. That makes base the base. So we end up producing water from those two things. Now we're left with potassium and iodine. Now notice I put the potassium first, even though it's listed here second. That's because potassium is the metal gets listed first. Potassium is a positive 1 charge. We can get that from the periodic table. Iodine is a negative 1 charge. We can also get that from the periodic table. We can also use context clues. Positive 1 minus 1 makes 0 for here. And the same thing down here, positive 1 minus 1 equals 0 here. That's because hydrogen is always positive 1 and hydroxide is always negative 1. So we can get the charges from the potassium and the iodine that way as well. Now we ask ourselves, does positive 1 and negative 1 make 0? It does, so we're done. Let's go up to this one. There's the hydrogen for the acid. There's the hydroxide for the base. So if we put those together, we get water. And we're left with the magnesium. That gets listed first. And the chlorine. So magnesium is going to be positive 2. It's because there's 2 hydroxides. It has to be positive 2. Or we can get that from the periodic table. Chlorine is negative 1. That's again because it's with 1 hydrogen, 1 chlorine. So we have that also. You can also get that charge from the periodic table. So we have positive 2, negative 1 here. That does not equal 0 the way it is right now. So we have to add a 2 here. Magnesium chloride, now it equals 0. 2 negative 1s and a positive 2. This one down here. Here is the hydrogen and the acid. We got these hydrogens too. This is part of a polyatomic ion. It's just that first hydrogen we care about. That's what makes it an acid. And then we have the hydroxide here. So we are left with water for that guy, plus then the aluminum CH3COO, which is acetate. So we can go to the periodic table and find the charge for aluminum, or we can see there's 3 hydroxides, which means that aluminum has to be positive 3. and then we can go here. We can look it up on our polyatomic ion sheet or see that there's one hydrogen, which means that there must be a -1. So if we go through this process, +3 and -1 does not equal 0. So we go ahead and put that in parentheses. Now it does equal 0. 3 -1s makes -3. +3 gets us to 0. The one thing that I haven't done here, guys, is balance. I'm going to get rid of the charges because those don't belong in your overall answer. They just help us get the correct chemical formula. And now we can go back and balance these things. So if we have 2 hydrogens here, we have not the right amount of hydrogens here, 3. So I'm going to put a 2 there and a 2 in front there, and that's going to balance it. Now I have 1, 2, 3, 4 hydrogens, 2 nitrates, this guy right here, and 2 nitrates. This one's going to be balanced the same way. We have a 2 in front of the water here, a 2 in front of the hydrochloric acid there. Now we have 1, 2, 3, 4 hydrogens, 2 chlorines, 2 chlorines. Now I can do this one. It's going to be balanced the way it is. We have 1, 2 hydrogens, 1 oxygen, and then we have potassium and iodide, potassium iodide. Down here, we're going to need to have more waters. We have, I believe, 6 of them that are going to be required, and put a 3 here, and that gets us our 1, 2, 3, 4, 5, 6 hydrogens. 1, 2, 3, 4, 5, 6, and 3 times 2 gets us our 6 hydrogens on the other side. There is our 3 acetates, that guy right there, and 3 acetates here. Hopefully this was a reminder. You can use this as help of coming up with the waters and the correct chemical formulas.